Okay, so we have already looked into how Boolean expressions or equations could be represented in the sum of products form, and there is an alternate canonical form called the product of sums. So in the previous case, if you remember, it was the sum of products, right? So what we were doing, we are ORing mean terms, right? So in this particular case, we are going to do the exact opposite. We are going to AND odd terms, right? So it's called the product of sums. Product stands for AND operation, and when we say sums is nothing but the max terms, right? We are basically referring to the max terms, which is again the sum of some literals, like all the literals that are present in the truth table. Okay, so this is what how the product of sums is going to look like. So one key difference while you try to construct product of sums is you need to choose those entries or those rows in the truth table that has 0 as an output. In case of sum of products, we were only choosing one, the output that had 1, and then represented the Boolean algebraic formulation for sum of products. I'll just rewrite it here. This is for sum of products. We choose 0 for product of sums, right? And here we, in case of sum of products, we use this as mean terms, right? Whereas in case of product of sums, we are going to use max terms. Okay, so this is the key difference. They are they're equivalent to each other. Okay, so just one more slide that I think we have previously covered anyway. So this is f is equal to a plus b plus c. This is one max term. A plus b plus c bar the second max term, and a plus b bar plus c, this is the third max term. So this is represented by 0 1 0, or the like we want to basically test out that what is the value, right? So a is equal to 0, b is equal to 1, and c is equal to 0, and the expression for f is this, right? And we want to find out the value. So if you technically see what this means is just plug in the values of a, b, and c. So we just did that here, right? So this is directly copied because a, b, and c, there are no complements. Here this is 0 complement because we have a c complement. Here it is 1 complemented because we have a b complement, right? And then we put it to a 3 input OR gate. Why there is a 3 input OR gate? Because here there are these 2 plus signs, right? A plus b plus c, there are 3 inputs. So this has to go to a 3 input OR gate. And once you get that, it is going to go to a 3 input AND gate because there are 3 terms, right, that we are ANDing. Okay, so here the output is 1. As you can see, at least 1 has to be 1. So here there is already 1, there is no question of looking. So here this is 0 and 0, but this 1 complement becomes 0, so the output is 0. And if at least one of the output is 0 in case of the AND gate, the output is going to be 0, right? So if you look at this representation 0 1 0, the output is really 0. That is also validated, right? So what the expression is, that a way of writing or representing the truth table, right? We just validated that the representation is correct, right? There is nothing more that we have done right now. Okay, so yeah, so this is something that you already know. Only one of the products will be 0. Anything ANDed with 0 is a 0. Okay, so similarly you can take up any of this term, right? Maybe you take up this term, right, and test out for the value of f, right? Let's say you can also do a sum of products instead of product of sum. You can represent this entire truth table using a sum of product expression, and test out the entries in the truth table. Okay, this is a very important exercise that you need to do. So currently we started from the discussion where I told you that you will be given a logical problem and that problem somehow you need to map to a truth table, right? So the problem that you are going to consider, we gave a very simple example of the tic-tac-toe game. You should definitely now try to come up with some truth table representation or some way to represent that functionality of the circuit and try to design the circuit. Okay, so what I, again going back to that discussion, is given that logical problem, by now you have the capability to map it to a truth table, and truth table is going to have the various inputs, and it could have multiple outputs, but currently we are just focusing on one output, single output, but circuits could have multiple outputs also, right? Just keep that in your mind. And given the number of input terms or input literals that we have, if you have k input terms, you can obviously understand that the total number of input combinations that can happen is 2 to the power k, right? So there will be 2 to the power k rows, okay, in the truth table. And as you can now see that sometimes it can become very exhaustive to represent that entire functional specification using a truth table, right? What you can always do, you can convert or you can represent the truth table now in a sum of product form or a product of sum form. Okay, so this is important. And the third thing I would like to also recapitulate is, please remember that the product of sum, POS slash SOP, these are canonical terms. These are canonical expressions. What is more important is not necessarily it's the minimal expression. Okay, so this is just a way of representing the truth table, and you can always come up with a circuit for product of sum or sum of product, as I have shown here. This is a circuit for the product of sum that we had. It's a always it's a two-level hierarchy, right? So if it is a product of sum, you have a first layer of OR gates followed by an AND gate. So as you can understand, every max term is going to require a OR gate, right? Whereas if you want to do it as a product of sum, the first layer is going to be an AND gate, right? Because we are going to have min terms. Every min term construction is going to require a AND gate, and after the output of the AND gates are OR together, right? So that is the sum of products. Okay. So depending on what kind of gate availability you have, what kind of logic you implement, and you can choose one of these canonical forms, right? Again, keep in mind, this is very important, is this is not necessarily the minimal expression. I have always already given you an example earlier that you can always simplify this. Okay, so simplification is the next step, right? You can always starting from a certain boolean expression, you can do further simplification. Okay, so this is sort of redundant, is how to write the product of sum expression. It is very similar to how we used to write sum of products, but it's just the different nomenclature, right? So I would say it's the same nomenclature, but a different way to write, right? It's kind of a complement of the sum of products, right? So it's the same truth table. This is your product of sum expression, and the max term form, you want to find out the truth table where the f is equal to 0. 0 in the input column is basically your true literal, right? So this is important. 0 in the input column is basically considered as a true literal. 1 in the input column is basically complemented literal. So there's a small things that you need to consider here, and OR the literals to get a max term, and AND together all the max terms. Okay, so this is how you need to write the max term form. Okay, so we can take this, this is A, B bar C. So just note that we are using a, b bar, c. A is 0, right? Here a is 0, but we are using the value a because we need to have 0 in the input column being treated as a true literal. Okay, so just the different convention, right? There is nothing very complicated here. It's just the convention is different. Okay, so 1 in the input column is the complemented literal. Okay, so here you have 1, so this is treated as b bar. Okay, and similarly for c, we have the same thing, and then you can always have multiple such max terms, and all you want to do is have a product of them. Okay, and sometimes it might become confusing. It's actually even very confusing to me, uh, the way you create the max term or the way you create the min term form. So min term is very straightforward. We are used to thinking 1 being the true literal and 0 being the false literal, and similarly we choose ones also in case of your sum of products. But in case of product of sum, think that everything is going to be reversed. The way you choose the rows is going to be, you want to only select the zeros as outputs, and even for creating the max terms you want to write, if a is equal to 0, that is not a bar, you want to write it as a, right? If b is equal to 1, you want to write it as b bar. Okay, so or remember, the product of sum of f is the same as the De Morgan's law. If you apply De Morgan's law on the sum of product of f bar, okay, so if you have a function f, right, you want to find out the product of sum, so it's basically product of sum of f. This is something that you want to find out, right? For example, the f is given on top. Okay, uh, here this is the same as the De Morgan's, so I will write De Morgan of the SOP of f bar. Okay, so if you take f bar automatically selects only the complementary entries, right? Wherever you have, for example, if you are choosing zeros, the entries that has zeros as output, f bar you want to choose the entries that have ones as outputs, right? You take the sum product of that and then apply De Morgan's law. So that is going to be equivalent to the product of sum of f. Okay, so we will do some practice so we will basically take some truth tables and try to find out the sum of product expression as well as the product of sum expression. And if we just practice a few examples, I think the concepts will become much more clearer, and you can also like get used to convert in between these two kind of expressions. Okay, so canonical product of sum, max term, we write it as capital M. In case of min term, we were using a small letter m. In case of max term, we were using the capital letter M. And here also we preserve the row order, right? The row numbers as 0 to 7. Okay, so every row has this shorthand notation. If we write M3, we always know that is 0, 1, 1. So the max term is going to be treated as A plus B bar plus C. So this is what you need to be very, very careful about. So if you choose M3, if it was given small m3, this will still mean 0, 1, 1, but the entry would have been different, right? So in case of 0, 1, 1 as a min term, you would have used a bar dot b dot c, right? But in case of a max term, we have to write the 0 as a, right? Not a bar. 1 as b bar, and c is again this 1. Okay, so this is going to be the case. Product, so instead of sigma that we typically used in case of to represent summation, in case of sum of products, we use this product term called pi. M stands for the max term, and 0, 1, 2 means that we want to only have this max term 0, 1, and 2. So somebody can very well understand what this means. Okay, so note that some final comments, you form the max terms around the zeros of the function. This is very important. But you form the mean terms around the ones of the function. Okay, that's the main difference. And this is not the complement of the functions, right? So don't think that zeros of the function, if you want to take, is the just the complement of the function, right? So if you want to you can just appreciate if you just do it yourself. If you just take a function and take a complement of that and then try to see what happens. Okay, so just keep this in mind. So mean terms to max term conversion is again simple. All that you need to know is how many literals were there totally. So if there were 3 literals, then you can have only mean term or max term from 0 to 7, because there are only 8 rows in the table, right? So if there are 3 literals, right, there should be 8 rows in the truth table, right? I'm writing as a TT, which basically means that M0 through M7. Okay, so it's because once you start complementing, right, you want to complement for example this M, right, from mean term to max term conversion. If you look at this set, you need a complement of this set, right? So there are 3, 4, 5, 6 and 7. So 0, 1, 2 was missing, right? So the totally you have 8 terms. Okay, so 0, 1, 2 was basically the M0, M1, M2, and the later ones are M3, M4, M5 till M7. Okay, so why you need to know? Because it could have been the case that there are 4 literals, right? If it was 4 literals, it is, so I'll write, if it was 4 literals, then you would have had values running from M0 till M15, right? So in that case, it is not only just 0, 1 and 2, but it will also be all the values from 8, 9, 10, all the way till 15, right? Because those are the things that are not appearing in the mean term, which means that it has to appear in the max term, right? That is how we choose even. Okay, so sigma m, sigma is your, always remember sigma is sum. So typically it is trying to indicate sum of products. This is your, this expression is pi your product, which is indicating product of sum. Okay, and this is for your mean term, this is for your max term. Okay, similarly for max term to mean term conversion also, you just need to take the complement of the row entries, right? 0, 1, 2 is given, you have to use the other ones. Okay, so one thing that you should always ask, if even not supplied, is you need to know that how many literals are there in the system. Otherwise all your calculations are completely going to break apart. So some conversions, so if you have, let's say, function f, right, abc, this could be equal to summation m 3, 4, 5, 6, 7. Okay, and f bar abc is going to be mean term 0, 1, 2. This is very easy to kind of understand, because if you have f as m 3, 4, 5, 6, 7, so these are the entries, I would say entries where value of f is equal to 1, right? So and then if you take a complement, right, the value of f, so that is f bar, that the value of f is equal to 0, right? So here will be so the value of f is equal to 0. Okay, and we know that apart from these values, the rest of the values were 0. So you can actually represent the same formula, but just f bar as summation of m0, 1, 2. Okay, so if you go back to the original table, let's say this was the entries that said 3, so this was 3, this was 4, this is 5, 6 and 7, right? And these were the 0, 1 and 2. So if we say f is basically the sum of these mean terms, right? Sum of these mean terms. If we take f bar, we are basically talking about these entries, right? Because complement of that particular function here, or the output where you have zeros, this will be 0, 1 and 2.